Hi everyone, Vega here. So today's video we're going to be looking at the ranking of planets and moons, but predominantly we're going to be looking at it by mass rather than size, which is what we normally tend to look at things as. So let's get to it. First of all, you might want to define what a planet is. At the moment we've got these 8 bodies that we've decided are planets, and as you might already see, there's at least 2 distinctions. There's 4 smaller bodies here, and 4 much larger bodies, and even within that distinction, the 2 much larger bodies of the huger gas giants and then the ice giants. So we can already begin to see that what a planet is certainly isn't its size, really, is it? Because there's no clear pattern between them there. And not only that, but there's Earth, Mars, Venus, but of course after that Ganymede is the next largest in terms of size, and we have to go all the way to here to Mercury to find the smallest planet. And until recently, of course, Pluto itself was a planet, which again is much further down the list. Even within these, so we might decide to call planets bodies for this purpose of this video. Perhaps you can argue with me in the comments if you feel differently, but obviously I've talked about the gas giants, but even within the rocky bodies, Earth is, as far as I'm aware, is larger than all of these bodies put together, and Venus pretty comparable to Earth, sometimes called its sister, at least in size. Earth and Venus are much larger than anything else. Then you've got this next tier, perhaps, where Mars and Ganymede and Titan, which are all pretty similar to each other in terms of size. Mars slightly bigger, Titan slightly smaller, but very similar. Then perhaps another ranking or tier of bodies where we have Mercury, Callisto, obviously often overlooked moon of Jupiter, and Io, another perhaps overlooked moon of Jupiter, but they're all relatively the same size. Then another tier after that, so we've got the moon, which we can see in our sky, so we know roughly how big that is. Europa, similar size. Triton of Neptune, of course, very cold world, and also Pluto in that tier. You might also include Eris, which is missing from this list, which is one of the largest newer bodies we've discovered. And then after that, another tier, really, going perhaps all the way down to Tethys, the moon of Saturn, some of the Uranus's moons, Titania, Oberon, another tier, and then obviously start to go into even smaller bodies. So in terms of size, there's many different ways you could describe the bodies of the solar system. But let's have a look at how that changes with mass. Well, this is to scale, so the Earth is going to be the same size once we get around to it. So if Pluto was purely just ranked on mass rather than its size, it would be so big, 0.00218 Earth masses, so a speck of dust on the Earth almost. Eris, of course, slightly bigger than Pluto, which is part of the reason why Pluto is not a planet anymore. But still a lot smaller in terms of mass than in terms of size. Triton of Neptune again, Europa, a lot of water on Europa, and then the moon. So look at the moon, size of the moon here. In terms of size, it does rank quite highly but in terms of mass, not quite so as impressive if you want to think of it like that. Volcanic world Io, again, Callisto, starting to get a bit bigger now, but nowhere near in terms of size. That's important in terms of mass. Now the first really interesting bit here is that we're missing somewhere. Mercury has now disappeared from the list, and we're onto Saturn's moon Titan. Again, smaller in terms of mass than in terms of size. Ganymede, again, same. And at last we find a planet. And if you look, the interesting thing here is Mercury, although it's smaller than Titan and Ganymede, is actually almost 3 times the mass of Titan. Mercury being 0.005 Earth masses, Titan 0.02, so double the mass of Titan, yet the same size, which can be quite confusing. So let's carry on. Now Mars. Now remember earlier I ranked Mars and Ganymede and Titan as the same similar sort of grouping. Well, not anymore, because Ganymede is 0.2025 Earth masses, whereas Mars now is 0.1, so 4 times the mass of Ganymede, whereas only relatively similar certainly in terms of radius at least. Here's Venus, doesn't change all that much, 0.9 the size of Earth, I believe, whereas 0.8 the size in terms of mass, so slightly smaller in terms of mass as opposed to size. And then for reference, there's our Earth again, which again is just 1 in terms of size and 1 in terms of mass. So again, this definition of planet and moon, it becomes a bit more difficult, doesn't it? Because Earth and Venus are clearly distinguished. Now, they were already distinguished from the other bodies before, but now look, the differences, and Mars is almost in its own category, more in a category perhaps with Mercury than certainly with Ganymede or Titan. So that might be an argument for saying for the planets being right, as Mercury obviously is a lot more important in the solar system in terms of mass than Ganymede or Titan, has a lot more pull. Okay, anyway, let's carry on though. We haven't finished here. There's our Earth again. Remember, Earth being the scale of 1, Venus and Mars, you can see there. Now here's Uranus, fairly large planet and also fairly large in terms of mass. But again, often we think of Neptune and Uranus as being the same, very similar planets, but in terms of size, Uranus is actually slightly bigger than Neptune, but in terms of mass, Neptune is quite a lot bigger than Uranus. It's 2 or 3 degrees bigger. Then the beautiful planet Saturn with its rings, of course. And again, this is on mass, not size, so relatively proportional to its size, its mass. There's our reference point again. So again, remember the Earth being 1 in terms of size and in terms of mass. And here's Jupiter, so much bigger. But I mean, the Earth is 1, so it's not going to change much. But in terms of times of, imagine fitting Mars into Jupiter, you could fit many, many times. But a mass of times in terms of mass. No pun intended there. But let's carry on as well, just to make things a bit more interesting. There's Jupiter in terms of its mass. Here's the Sun, which is 1,038 times. So if you used to get this and put it at 1,038 times, that's how big the Sun is in terms of mass. So you might think of so often we talk about the solar system as being the Sun as the centre, but of course it's not actually the centre of the solar system. There is what we call a barycenter between the Sun and the planets, of which Jupiter is by far the largest, as we can just see in terms of mass, which is what's important. So you might think of the Sun slightly orbiting this smaller body, and this smaller body orbiting this larger body, with a barycenter somewhere inside the Sun, but not in the centre of the Sun. Anyway, thanks for watching. Don't forget to add a like and a subscribe if you found this video interesting, and I'll see you on the next one.